Today's lesson, surface area and volume of 3D shapes. We will determine the surface area and volume of rectangular solids, spheres, cones, and square or pyramid. Basically, we are looking at these two. This is rectangular solid, a sphere. Well, then we'll find the surface area and volume of a cone and a square pyramid. Notice a square pyramid, the base is square. There's also rectangular pyramids, in that the base here is rectangular. For today's lesson, we'll be looking at a square pyramid. The same formula will apply for also a rectangular pyramid. You will need to complete these assignments your formula sheet. Circumference, this is what we have. Then we're looking at our formula for 2D shapes. And on the flip side of your formula sheet, you'll have the figure. These are the name of the figure in the diagram, and the surface area and volume. So we will be applying these two formulas for each solid or object. Here you have a sphere, surface area and volume, cone. The previous lesson we looked at cylinders, and we looked at triangular prism. So today we'll be looking at rectangular solids, spheres, cones, and pyramid. In this case, we're looking at a square pyramid. Let's look at the first example question. You have to calculate the surface area and volume of each of the following shapes. So this is a rectangular solid. So you can and the reason it's called rectangular solid, it's like a box. So mathematical name. It's a rectangular shape, and the sides are rectangular. The front, in this case, is square. But because the sides are rectangular, it's called rectangular solid. This also is called a cube if it's all the sides are equal. So a typical would be like a tissue box, would be an example of a rectangular solid. So it asks us to find the surface area. So the first thing we want to do is to write down our formula. And we will go to our formula sheet. And we find that the formula is surface area is 2 times the length times the width, plus 2 times the length times the width, height, and 2 times the width times the height. So essentially what you're doing, you're finding the top or bottom, which is the length and the width, the front and the back, the length and height, and either side is the width times the height. Since your opposing sides, we multiply by 2. So the top and bottom, length times width, so 2 is the same. So that's how we derive that formula. So I'll record my formula here. So I'll write it here, which is 2 times length times width plus, I'll put a bracket around these here, so I wouldn't confuse. Then we have 2 times length multiplied by height, just a little bit of length, plus 2 times width times height. The next step I like to do is to label the diagram. So if you look back to your formula sheet here, you can find what's the width, what's the height, and this is your length. So your width would be, here's your width, this is your height, and this is your length. The length of the box, the height of the box, and the width of the box. It's all recorded beside here. So we have our length is 30. Our height given is 8. And the width is equal to 8 meters also. Next, I'll substitute the values for the dimension into our formula. So what do we have for L? You replace L with 30. Width, replace that with 8. So let's go ahead and do that. So we have 2 multiplied the length, replace L with 30, multiplied by the width, which is 8. Plus 2. Now the 2 is there before because there are 2 faces or 2 sides with the same dimensions. The length is 30 multiplied by the height, which is 8, plus 2 times the width, which is 8, multiplied the height, which is 8 also. Then we worked out our calculations. We have this is equal to 2 times 30 times 8. And you can go to your calculator to do some work here. So we have 2 times 30 times 8 is 480. Now let's just say 2 times 30 times 8, so that gives us 480 also. 2 times 8 times 8, so 64 times 2 will give us 128. So we add them all up. So the surface area is equal to 480 plus 480 plus 128. So plus 480 plus 128 gives us 1,088 square meters. So 1,000 square meters. Because the surface area has to be squared. That's why we put to the power 2 there. So we'll highlight that. We found our surface area. Now we're going to find our volume. We've already established our dimension here, so I'll highlight these because we'll be using them again. So I'll highlight. So surface area. So this is my formula for surface area. Now I'm going to find the volume. So step 1, I go to my formula sheet. And from your formula sheet, you'll find the volume is length times the width times the height. So length times the width multiplied by the height. We've already determined from our diagram our length and height. So we'll substitute the length, 30 for the length, 8 for the width, and 8 for the height. So the length is 30. Multiplied by the width, which is 8. Sorry, the height, width, and the height is 8 also. So 30 times 8 times 8. So I'll calculate it out now. So 30 times 8 times 8, it gives me 1,920. 1,920 cubic meters now. So this is cubic now, not because we're doing with volume. Volume is 3 dimensions. And you can tell from these here, you're multiplying these 3. Length is 1 dimension, width is 1 dimension, height is a 3rd dimension. So just recall step 1, record once you identify what solid it is. So we use a rectangular solid. Once you need a rectangular, it's a rectangular solid, you go to your formula sheet to discover the formula. Then we record the formula down. The next step, we look at our diagram and label it width, length, and height based on what our formula requires. Then once you determine the dimensions, substitute the value for the width, height, and length into our formula, and then you do your calculation. For surface area, it's squared because it's 2 dimension. For volume, we record the volume formula, substitute the value for the length, width, and height, calculate to give you cubic. So the next example, for a sphere. Now, a sphere like a basketball or a soccer ball or an orange, more or less it's round, although sometimes the orange is not as round as you would like, but that's what it is. The surface area is 4 times the pi times the radius squared, twice the radius. The volume is 4/3 pi times the radius to the power 3. So the only dimension we need from a sphere is the radius to find the surface area and volume. As compared to the rectangular solid, we need 3. All we need here is the radius. So let's record our formula for surface area. So surface area of a sphere is 4 times pi multiplied by radius squared, or radius times radius. Some people like to write like this here, 4 times pi times radius times radius. So these are together, squared. Now let's look at what we need. We need our radius. So I'm going to highlight the formula. Okay. Our radius, say, is 37 millimeters. So we can record that here. Radius equals 37 millimeters. So this gives us 4 times pi radius, which is 37 squared. Now I go to my wonderful calculator to do some, oops, let me take away from it. Okay, maybe this might help. So we have 4 times pi multiplied by, I'm going to put a bracket here, 37 squared. Bracket. It gives me a result of 17,203.36. So surface area is equal to 17,203.36 36. And it's in millimeters, so square. Next, we go and find our volume, the line here. So volume of a sphere, and we go to our formula. It says it's 4/3 times pi times radius to the power 3. So if we record that, 4/3 times pi times radius to the power 3. So we need our radius. That's the only dimension. This also could be written as 4 times pi r cubed divided by 3. And you look at the bracket around that. Which is 4/3 pi, and the radius we know here is 37 cubed. Now we go to our little calculator here, and let's do some work for us. Now, for some of you, depending on your calculator, you may want to work backwards. And I'll show you both ways. I'll work backwards because you may have trouble with your 4/3 depending on the calculator you're using. I'm using a graphing one because there are a lot of possibilities with this one. Well, let's say you don't have a calculator like this graphing calculator. You have a basic calculator. The best way to work for this is to work backwards from the back here coming to the front. So I'll put bracket 37 square. Now, if you do not have a bracket in your calculator, most scientific calculator does, but if you don't, you can simply put 37. Now, you need cube here. If you cannot find this cube button on the calculator, you just multiply 37 by itself 3 times. So 37 to the power 3 is the same as 37 times 37 times 37. So that gives me 50,653. Then I'll multiply it by pi. Now, I now have to multiply by 4 and divide by 3. So you can multiply this by 4 now, then divide it by 3. So it gives me a result of 212,174. So I'll work this out so you can. So some more space on the side here. So I'll replace this over here. So this 37 would be 37 multiplied by 37 times 37, multiplied by pi, multiply by 4, and divide the whole thing by 3. So this you end up with, I'll put a line here so that tells me it's separated. It gives me this large number here is 4 multiplied by pi multiplied by 5653. All of this divided by 3. It gives me a result of 212,000. 174.79, and it says volume has to be in cubic centimeters. That's the final answer. That's a long way of doing it. Another way, if you have a scientific calculator in hand, you can go straight and work from left to right. So what you'll do, you put a bracket, 4 divided by 3, close bracket, multiplied by pi, multiplied by 37. Now I have a power button here I could use, and it'll give me the same result. 212,000. Another strategy you could use, if you can go 4 times pi multiply by, now if you don't have a power button, you can put your 37 times 37 times 37, close bracket, and divide it by 3. So the different ways of using your calculator to arrive at your final answer. Let's look at the surface area and volume of a cone. Now, cone, notice it's, if you look at the surface of a cone is pi r times L. The L refers to the slant on the side of the cone here. The height is a perpendicular distance from the center of the cone to the top of the cone. Now the pi r squared is the bottom, is a circle. If you look at any cone, it's circular. So the side of the pi r, and r refer to the radius, times the slant height. So the slant here, called the slant height. And the radius is this from the center, bottom of the cone, to the circumference of the circle. The volume is 1/3 pi times the radius squared times the height. So we need the height, the radius to find the volume, and we need the radius and the side length, or the slant height, to find the surface area. So let's record. So let's look at the first one. We're looking at surface area. And that is equal to pi times the radius times height. Plus, so this is the side. And the bottom, which is right here, is pi r squared. So I'll write it out here. This means radius. So make it more compact, pi r times h plus pi r squared. So you have the side and the bottom. Now we go to our dimension and find our dimension. Here will be radius. Now the diameter is 6. So this is your diameter here. Your radius is half the diameter, which is 3 inches. This is your h, and this is your L, slant height. So we can record L is equal to 5 feet. R is equal to 3. 3 feet, essentially 3 feet. And this height is 4 feet. Next, we substitute the values given into our formula. In other words, replace r with 3, h with 4. This is that pi, or radius, is 3. And our height is 5. Plus pi, our radius is 3 to the power 2. Now go to a calculator. This would give us 3 times 5, 15 times pi. Now that's very difficult to do in my head, so I'll get my good friend calculator here to do the work. So pi times 15, 47.12. That's feet plus pi times 3 to the power 2, which is basically pi times 9. So give me 9 here. $28.27. So I'll remove this from here. So total, add the two wonderful guys that we get here, plus 47.12, 75.39. Or we can round up. So 79.39. And this would be our square feet. Surface area of this cone then is 79.39. Next, we go ahead and find its volume. And this is where we're going to go to our formula sheet again. And our volume is 1/3 pi r squared times height. So let's record that. Volume is equal to pi plus 1/3. 1/3 pi r squared times the height. You can also write this as pi r squared times h divided by 3. Probably an easier calculation. Or pi r squared times height divided by 3 in terms of calculation. So we know our height from when we calculate our volume. So we have here, so we have 1/3 pi, the radius, sorry, we need a radius here, and also, which is 3 to the power 2 times our height. And our height here is 4. To make my calculation easy, I'll just divide the whole thing by 3. Don't really need this 1 anymore because it's understood 1 times everything except for 0 is whatever the value is. Now, work all these out. We end up with pi times r cube, 3 squared times 4 will give me, oh, here's my calculator here. So I have pi times 3 squared times 4 gives me 113. So this is 113.097 divided by 3. So I'll divide that by 3. Gives me 39.7. So round up. 37.70. And that will be in cubic feet. So recap. Step 1, identify 3D shape. And then go straight to find the formula. Step 2, label the dimension of your shape. Then substitute the value given for your dimension into your formula and then calculate. The surface area. The same thing that applies for the volume. The formula, then you substitute the given values into your formula. Here we're looking at a square pyramid. It's a little bit confusing here. The slant here is 30 and the perpendicular height is 28. Somehow we have 2's written there. Sorry about that. Typo there, but this is just one dimension here. The height, street height. This has nothing to do with it. So this is the perpendicular distance from the center of the square to the top of the pyramid. Now this is square pyramid, and this is goes to our formula sheet again. The surface here is the base square. The base refers to the bottom of it. Now, because it's a square, it's the length times the width. The length and the width are the same. That's why you can say base square. For example, this is 4. This would be 4. So 4 times 4 is the same as 4 to the power 2. Two times the base, the length of the base here, multiplied by the side length, or sometimes referred to as the slant height. It's referred to as not the perpendicular height here. Okay, we'll need that perpendicular height to find the volume. Okay. So first step, we want to find the surface here. Record our formula. Surface area of a square pyramid is your square, which is the bottom, plus the side. Side will give us 2 times the base. Essentially what you're doing here, these are 4 triangles. Right? And you're really finding the area for the 4 triangles to the side and the area to the bottom, which is a square. But because there are 4 triangles, you don't need to divide by 2 because the 2 will literally cancel. So step 1, we have our formula for surface area. Step 2, we are going to label the diagram. So this is B here. Your height is H, 28, and this is your L. Now, the slant height in the formula refers to as your S. So your S is equal to 30 base is equal to 20 and the h is equal to 28. Just record that here for our purposes. Here we have b is equal to 20 centimeters. Our slant height, according to our formula, is 30. And our height, perpendicular height, is 28. So now substitute our values into our formula. So b, I'll rewrite it here to make it look. B squared, so b is 20, and to the power of 2. Use brackets that tells you have to multiply 20 by itself. Okay. Plus 2 of the bracket, and multiply by your base, which is 20, multiply by the side length or the slant height, which is 30. So surface area. So 20 squared is 400. Plus 2 times 20 plus times 30 will give me what? 1,200. Add the 2, we have a 1,600 centimeter squared. So surface area is 1,600 centimeters squared. Now we'll find our volume. So we have volume, our formula for volume. Oops, that's right. If we go to our formula now, is 1/3 base squared times height. So we write that as 1/3 the base times height. Okay, that's base squared. I'm looking for my highlighter. Now I'm going to substitute my given values into my formula. So my base is 20. So I have 1/3, base is 20. Don't forget to the power 2 times your height, which is 28. Now I'll rewrite this as 20 squared multiplied by 28 divided by 3. This comes out to be, if we do that, gives me what? 1,100 and 1,200. Let's double check. So we have 20 squared multiplied by 28. 11,200. Okay, is that right? Divided by 3. And this will give me a result divided by 3733. And that will be in cubic centimeter. So let's review. Today, our goal to determine the surface area and volume of rectangular solid, spheres, cones, and square pyramids. First object we looked at, example, is a rectangular solid. The first step, identify the name of the object. Next step, after that, we could find the formula for the surface area and the volume. Then determine the dimension, record the dimension, substitute or take what the dimension is and replace the length or whatever dimension in your formula with the dimensions given on the object and calculate. That applies to all of the surfaces, sphere, and cone. Just be careful with cones. It's slightly different. And the square pyramid. In subsequent assignment, you'll be given rectangular pyramids. And in that case, it wouldn't be base square, it would be the length times the width. Everything else will be the same. If you were to remain. So now, if that changes, if they give you a different length and width here now, this entire formula changes. So right now, we're looking at square pyramid. The base here the same. So this formula only works for square pyramids. Should indicate that, only for square pyramids. This will not be the same formula you will use. It's related, but this will not be base square. It will be length times width. And then this will change because the different dimensions here will be different. So this side will not, say it's 30. So now you have to do for two sides, which should be the same.